back to the operation management class. In this video, we will learn about the technique in operation management, which we call it critical path method. This technique is useful when the time is deterministic. Let's see about that in detail.
The critical path method. In this video, we will discuss about this method that is used for scheduling or for controlling the project management. In the project management life cycle, this method is commonly used in the scheduling or controlling. What is critical path method? As we know that the project is made up or it is consists of a sequence activities that form a network. We should highlight this one, that this sequence of activities should form a network that representing the whole project. The path that is taking the longest time passing through all of this network of activity, we call this one the critical path. The critical path method helps, in this case, the method in identifying the critical path method help to identify the critical path in the project network. That is why the name is critical path method. And this network is firstly developed by DuPont for chemical plant in 1957. Critical method is answering the following question. The first question that is being answered by, that can be or possibly answered by the critical path method is, when will the entire project be completed? At which date? What are the critical activities or tasks in the project? So we can determine which activities that is critical and which activity or task that is not critical. So we need to pay attention to the critical ones. Then this is also which are non-critical activities. Non-critical activities is the activity that having a slack time, having an allowance, an allowance. Number 4, is the project is on schedule, behind schedule, or ahead of the schedule? We can determine this, by predicting when the project is to be completed. Number 5 is, if the project must be finished in shorter time, what is the way to accomplish this one? So this one, we can do this, we can accomplish this by the technique that we call it project crashing. But for sure, we need to understand, we need to determine when the project be completed first before we apply the crashing to the project. How we represent network in the project? There are two ways in representing the network in the project. There is activity on node and the activity is on arrow. These two figures illustrate the difference between these two representations. In the left hand side, activity on node, so A, B, and C is an activity and it is written, it is represented inside the node. But on the right hand side, the activity of A, B, and C is not represented on the node. Instead, it is represented on the arrow. Number 2 is also the same. When we have the situation is like this. A, B activity must precede the C activities. In representing in activity on arrow, it's become like this. And the third one, the situation is like this. This is the representation in activity on arrow. So take a look at the example of a bunch of activity of a project that has this characteristic, has the immediate predecessor that is written in here. How we can represent all of this one into the network representation? In this case, we will use activity on node. we see in here that, okay, let's begin. This is start in here. And then simply after start, there is an activity of A. Since activity of A and also activity of B doesn't have an immediate predecessor. So this is actually the start. Yeah, the start of the project. And then let's see, and then activity C, yeah, activity C should, yeah, in this case, the predecessor of the activity of C is A, yeah, as we see in here. So we put it after A is C, and then another one that need A is D in this case. So D we put it in here. So C and D both need A as a predecessor. And then D itself, yeah, need B as a predecessor. So we draw like this. So B is a predecessor of D, and then we will continue further, yeah, to draw that E and F, and the predecessor is C. So E and F. So the successor of C is E and F. G in this case, yeah, has the predecessor D and E. Yeah, D and E should be done first before G, and then lastly H should be done, yeah, after F and G. So this is the representation, network representation of this kind of example. How we can do the critical path analysis? Let's take a look first, yeah, about the terminology and the symbol that we will use in the critical path analysis. So we make a circle, the big circle, and we divide it into several regions as it is represented in here. Then the activity name or symbol, we should put it in here. So I put it simply the activity symbol A, and then the activity duration. So we put it both of activity name or symbol and the activity duration in the middle of this circle. And then on the left hand side, we divide it into two areas, and the right hand side also we divide it into two areas. The upper one, we call it, yeah, the left hand side, and upper one, we call it the earliest start. Yeah, so the left hand side is the start region. The right hand side is the finish region. The upper side is the earliest, and the lower side is the latest one. So we can simply define this one is earliest start, this is latest start, and then at the upper right is earliest finish, and then at the lower right is latest finish. So this is the symbol. So this is the representation that we will use in critical path analysis. How we can do that? First, we need to do a forward calculation, and then we return back with the backward. Yeah, let's do the forward calculation first. As we already draw in the very beginning, that this is the network structure of our example. So this is, and we draw each activity and each duration inside in the center. A activity duration is 2, C is 2, B is 3, and so on. And then let's start from A. The earliest start, yeah, A here is 0, and then the earliest one, and then 0 plus 2, yeah. So when we return back to here, our definition, earliest start, earliest finish for this one. So this one is earliest start, and then this is earliest finish area, and then this one is latest start, and this one is latest finish. So 0 plus 2 equal to 2 in this case. So when A finished at 2, and then C also should be finished at 2, and then 2 plus 2 in here plus 2 equal to 4. Yeah, and then we see that when C finish at 4, and then F should be start at 4, and this E should be also start at 4. Okay, and let's do for the activity B. So B in here starting from 0 plus 3 and then divide 3. If B finish at 3 and then D should start at 3 here, and then 3 plus 4 equal to 7. Then, oh, let's see in here. Activity E and activity D. Activity D finish at 7, but activity E finish at 8. So which one that we should put in G? So we should put 8 instead of 7, because the activity E finished at 8 and D already finished, so D should wait. Yeah, should wait for E, because G need D and E at the same time. So this should be 8 in here, and this is plus 8 plus 5 becoming 13. And take a look at here. So we have 7 as earliest finish, and then we have G earliest finish of G is 13. So this should be using the same rule as in here. So this should be 13, and then 13 plus 2 becoming the 15. So this is the forward calculation. So we, from here, what should we do is doing the backward calculation. The backward calculation is basically starting from the end of the activities, yeah, and then to the beginning, Okay, let's take a look how we can do this. Yeah, so 15, yeah, starting from 15 minus 2 is becoming 13, and then 13 in here is, this is the letter start. So letter start of activity H becoming 13 in here. So, and also 13 for activity G. And then let's move on. Yeah, 13 in here minus 5 becoming 8. And then 8, yeah, 8 in here becoming 8 over here for E, and then 8 also for D, yeah, and then we continue 8 minus 4 becoming 4, 4 move to here, and then 4 minus 3 becoming 1. Okay, let's take a look at this section. So E, 8 minus 4 is equal to 4, and 4 in here. So 4 is becoming the latest finish. So the early latest start of E becoming latest finish. 4 minus, yeah, 4 in here. So we see here. Why this is 4? Yeah, why this is 4? Since we have, oh, take a look at this case. So we have 13 in here, 13 minus 3, and then it's becoming 10 over here. But let's see, we have 4 and we have 10. So we have two letters start of F and letter start of E. Yeah, one with having 10, one with having 4. So we need to decide, so which one we should use. So in this case, for the backward propagation, we should take the minimum 1. So in this case, minimum 1 between 4 and 10 is 4. So 4 minus 2 becoming 2, and then 2 move to here, and then 2 minus 2 is becoming 0. So we already complete, we already fill all of this number in this figure, in this network analysis. So which one is the critical path in this case? So the critical path 1 is determined by seeing, just simply see from here, which activity that having earliest start equal to latest start, or earliest finish equal to latest finish. So we can do, or we can use both of these criteria. So based on this criteria, so we have A activity is critical, and then we have this is no, this is C here is critical. So we have, how about this one? Oh, this is not critical one. So this is should be E in here, and then this one G, and then H. So the critical path for this one is activity A, C, E, followed by G, and then lastly H. So we need to pay an attention, put our resources to keep these critical path activities works accordingly. So here, yeah, this table shows the critical path analysis were similar with our analysis before, that this activity A, C, E, G, and H is the critical path since they don't have what we call it slack or allowance. So you may see here they have all zero allowance. So when either one of these activities is late, all of the system, all of the project completion is late. So thank you so much for joining me in this video about the critical path method. Let's continue the discussion about the PERT, yeah, in the next video.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.